Sweet. Okay, so where were we in the story of calculus? So in first year we saw these kinds of single variable integrals, and for us those represented areas. Right, the area, signed area under the curve from A to B. Then we met this notion where we integrate over a region. Right, so we've got some region, and when we integrate, that represents volume. Right, so we might imagine the volume underneath our graph as being the double integral. But now that we've got functions of many variables, we can integrate some things with 3 variables. Okay. So if we've got a 3-variable function, and we integrate it out, we get something, we get a number, and that number represents a volume of a 4-dimensional object. So some people call this hypervolume.
Hypervolume.
Very fancy. So this is the volume of the 4-dimensional region lying underneath the graph of our 3D function. Okay, so this is usually a sort of a strange concept. One more sort of physically realistic interpretation that I find helpful is the notion of measuring the density of an object. Okay, so we have sort of a better physical intuition for measuring the densities of physical objects. Okay, so let's say we've got an object with density that has 3 variables. So at different points in the object, it will be different densities. So you might say, imagine a water bottle. The metal part is quite dense. The plastic part is less dense. Right? It's lighter. We can get its weight by integrating out the density over the whole object. Okay, so density is a function of where you are in the object, and when we integrate it over the whole thing, we get a weight. Okay, this is sort of a easier thing to think about than hypervolume. But let's see the mechanics of how we actually do this process. So this is a triple integral. The region that we're integrating over is the unit interval to the power 3. So this is we want every point in our region to have x coordinates between 0 and 1.
X plus y plus.
So this is a cube. we get something like this, and we've got some density in this that changes based on where we are in the object. So at the corner here, at the origin, we have very low density. We have 0 kilograms per meter cubed. And then as we move up to this vertex 1, 1, 1, our density goes up to 3 kilograms per meter cubed. Okay, so different places in this object weigh different amounts. And we want to find out the total mass of the thing, the total weight. Okay, so we need colored chalk. So in order to handle something like this, we need to pick an order of integration. So which variable do we integrate at first? Here, the function's super duper symmetric, so there's not any particular order that we would care about. So we'll pick X, Y, Z. We'll put them in alphabetical order. And now we need to put in our bounds on where the integration happens. Okay, and now we proceed just as we would with a double integral. We'll work from the inside outwards. So we'll do dx first.
Yesterday, the video was two couple of breakers and we stopped and we said we haven't covered in the lecture.
So when we take the antiderivative in x, we get fundamental theorem of calculus. We put in our bounds, 1 and 0. Now we do the thing in y. Go into the y coordinates. Here. And now we're back to the land of single variable integrals. And somehow this density sort of makes sense somehow. If we're thinking about this thing, it's got volume 1, and the density goes from 0 all the way up to 3. Right? So somehow we've got something less than density 0, or sorry, bigger than density 0 and less than density 3. Right, so this one matches what we'd expect. Thoughts or comments there?
We do it either way, right?
Yes, yeah, you could totally integrate this in the order.
Is it usually we take average density?
In any order you want to pick will give you the same final answer. So in two variables, we could switch dy and dx, and we get 2 possible ways of calculating. Here, we've got 6 possible ways of rearranging these guys. Okay, so this is sort of analogous to integrating over a rectangle, right? Where here we've got some kind of cube, right? We've got some straightforward region where we just put in the bounds here and here, right? And now we'll go and do that integrating over a region, a general region.
That is the main thing. Mouse thing. तुम्हें पता नहीं क्या बोल रहा था ये कल तो जो पेंट मॉडल में कैनवास है ना इसको इधर लाओ यहाँ से डायरेक्ट ड्राइंग करो जो लाइन पहले बना रहा हो ना उसको फिर जो बैकग्राउंड कलर है ना उसके तरीके से
One property of these three-dimensional things is that specifying the boundaries gets a little complicated.
देख जो हम ओवर करते हैं और फिर ऐसे जाते हैं अगर वो ड्रॉ नहीं करनी कहते हैं उसको बैकग्राउंड कलर से ड्रॉ कर दो टेक्निकली वही है ये सही है इसको एरे लिस्ट को देख सही आ रहा आज है बात कैसे भी करके ख़त्म करना है सिर्फ कल के लिए फ्लोटिंग पॉइंट रह जाए जैसे मतलब मुश्किल है क्या सेव वाला मुश्किल है
So now we've got
सेव
a
वाला तो वो बोला आसान है सबसे सेव वाला
3D shape,
पार्सिंग वाला मैं करता हूँ
and we want to integrate over this. I'll suggest the following first step.
पार्सिंग में ना वो FSM बनानी है फाइनाइट स्टेट मशीन
So first step, try and sketch the region, and then that'll help you pick appropriate bounds for setting this thing up. Let's take maybe, oh, I don't know, 5 minutes, please.
Where do we get set? How do you draw? How do you draw x equals to -1 here? And here? Some like this. -1. Because 1 is here. -1 is here. But why would it intersect the z-axis and the y-axis? I don't know. But because this is on the paper, so usually it's a 3D thing, so it won't intersect this. For what? This is so hectic. Sorry? Like how?
Because Z is curved, right? And the
Yeah. Z is 1 minus x squared. Yeah. That is a hemisphere. Yeah. That's strong, isn't it?
No, it's not.
Sorry?
This isn't a because it has two flat sides.
No, I'm saying like the half of this sphere is called the hemisphere. हाँ भाई चल तो रहा है पहली वाली लाइन गायब हो जाती है यही तो मजा है यही तो मजा है करो पहले क्यों गायब होती है चेक करो I don't know.
Sure.
What? 1 more x square? So this doesn't have so z-axis and the x-axis. There's no y-axis involved. So it goes like only, but I don't know. Yeah, so just do this. Oh, z equals to 0, z equals to 1, z equals to 2. So z equals to 0 is, yeah. So x, so what is that?
हो गया
Huh? हो गया?
क्या मैंने गलती कर रहा था मैं
हाँ? चलाओ एक ही कमांड है करो टिक करो अब इस हिसाब से वो करो
क्या राइट